Alright, boys and girls, this is Mr. Manise here with a very special video for you guys. And in this video, we are going to talk about the different characteristics of a quadratic graph. We've got all these different qualities, traits, and characteristics that we're going to ask and we're going to try to answer. And before we answer any of these things, we need to be able to graph our quadratic. And then after we graph it by hand or on our graphing calculator, then we'll be able to answer these questions. So I'm going to show you guys how to graph it using your graphing calculator, and then I'm going to show you how to graph it by hand. So let's just go ahead and jump right in and take a look at our first example here. So in this first problem, I have f of x, and remember f of x and y equals, those are basically the same thing. So if I really wanted to, I could just change this to y equals. It means the same thing. So in this first problem, I have y equals x minus 3 parentheses squared plus 1. So notice in this first problem, we are actually in vertex form. How do I know I'm in vertex form? Well, I have this parentheses squared piece. I have a binomial that's inside the parentheses. So that lets me know that I'm in vertex form. But it doesn't matter whether I'm in vertex form or standard form. I can graph it both ways. And let's just refresh our memory on standard form and vertex form. So standard form, what we're accustomed to seeing, standard form would be ax squared plus bx plus c. That's what we're used to seeing. Okay, so I have an equation something like this: y equals 3x squared plus 2x minus 4, something like that. Vertex form looks a little bit different. So vertex form would look like this: y equals a times x minus h squared plus k. Okay, so that could be something like this: y equals 3 parentheses x plus 4 squared minus 5, something like that. Okay, so up here I'm in vertex form because I have that parentheses squared piece, and over here I'm in standard form that we're accustomed to seeing: y equals ax squared plus bx plus c. Okay. Alright, so we're in vertex form. Y equals x minus 3 squared plus 1. So we're being asked to find the x-intercepts, the y-intercepts, domain, range, all these different things. So the first thing that I want to do is I want to graph my quadratic. So I'm going to use my graphing calculator. So turn the calculator on, and the first button I'm going to press is y equals. Y equals is up here in the top left of your calculator. Or it's in gray there, so I press y equals, and now notice that I can plug in a whole bunch of different equations. So I'm only going to plug in one at a time. So let's go ahead and plug in our quadratic equation. I'm going to type it in exactly the way that I see it. I'm going to type in my function. I already have the y equals, so I'll type in parentheses. My X button is up here where my finger is, just to the right of the green alpha button. So open parentheses, X. Now this is real important. I don't want to press the negative button. Okay, the negative button is down here where my finger is at the bottom of the calculator. That's the negative button. This is the minus button or subtraction button. Okay, I need to make sure you guys are well aware of the difference between those two buttons. Okay, so I need to press minus 3. X minus 3, close the parentheses. X minus 3, close the parentheses. The little squared button is right here where my finger is. Okay, a few buttons below the green alpha button. There's no reason to put raised to the second power because I see some students doing that. There's no reason to do that, so I'm going to delete that. So I just need to press the little squared button right here where my finger is. X minus 3 squared plus 1. Okay, so I'm going to give you guys just a second just to make sure you guys have that plugged in your calculator. And I want you guys to do all these problems with me. I want you to physically be typing these buttons into your calculator as we're going through these problems. It's one thing to watch me do it, but it's a whole other thing for you to get in there and do these things yourself. Okay, so I have my function typed into my calculator. So now I'm going to press the graph button. Okay, so that's in the top right where my finger is. So I'm going to press graph. And the reason I want to graph is I want to see what my quadratic looks like. Okay. Now, if you graph your quadratic and your windows look all kind of messed up, if you're zoomed in or zoomed out, you can press this zoom button here in the middle. I can press zoom, and I can select option number 6 and zoom standard, and that gets my window back to 100%. So it's kind of like a Microsoft Word document. If you're zooming in 200% or zooming out 50%, if you press zoom standard, that gets you back to your normal window. Everything's at 100%. Okay, so hopefully you guys have a graph that looks like this on the calculator. Okay, and the reason I want to graph is I want to figure out where's my vertex. What is the minimum? What is the maximum? Well, in this case, I don't have a negative in front of my x squared term. So there's no x-axis reflection, so there's no flip here. So I have a regular right side up u, okay, so this is a normal quadratic equation, normal quadratic graph. So I definitely have a minimum. Okay, think about a roller coaster. My roller coaster is coming down, and then it hits a bottom, hits a minimum point, and then it goes back up. So I have a minimum. So if I want to find the vertex, the way that I do that is I press second calc, and this calc button is above the trace button. in blue. And remember, anything with a graphing calculator that you want in blue, you have to press the blue second button first. So I want second calc, it just stands for calculation. So I'll press second calc. And now notice that I have a whole list of menu options here. I want the vertex, which in this case we said it was a minimum. Okay, sometimes it's a maximum. If it's upside down, then we have a maximum. But in this case, our graph comes down to a minimum point. So I'm going to press second calc, and I'm going to select option number 3, minimum. Okay. Now notice here your calculator says left bound. Okay. So all that means when it says left bound, right bound, all your calculator wants you to do is it wants you to tell it, where do I want to bracket the point that I'm trying to find? I'm trying to find literally where my pen is. I'm trying to find that low spot, the vertex of my graph. So I'm trying to tell my calculator, Mr. Calculator, I'm bracketing this point right here. I want you to find that point right there. Okay. So I need to move. We have this little guy called Mr. Spidey. Mr. Spidey, here he comes, Mr. Spidey. He looks like a little spider on a spider web. So Mr. Spidey, there he is on the spider web. So I can scroll left and right. I can move him up and down. Okay, so I'm really only going to be using these left and right arrows to move Mr. Spidey. So when it says left bound, I just need to move Mr. Spidey somewhere physically to the left of this point. So if you want to think about drawing an imaginary line down through the axis of symmetry, which we'll talk about in a second, if you draw an imaginary line down through the middle of my quadratic through the vertex, I just need to pick a spot anywhere to the left. And it doesn't matter where. I can be really, really close like that. I can be a little bit further up the spider web up here. I can be way off the screen. It doesn't matter. I just need to pick a spot to the left of the vertex. I'll pick that spot, and that's fine. I'm going to come down here to the bottom and press Enter. So I'll press Enter. Now notice my calculator saying, okay, all right, Mr. Maniz, now I need a spot to the right of the vertex. I need a right bound. So I'm going to move Mr. Spidey somewhere physically to the right of the vertex. Again, the vertex is right where my pen is. I just need to move him anywhere to the right of that spot. That's fine. That's fine. Way up here is fine. Anywhere to the right is fine. I'll leave it right there. That's good enough. I'll press Enter a second time. Now notice my calculator says guess. Do you want me to guess? Mr. Maniz, are you ready for me to guess? Yes, Mr. Calculator, I'm ready for you to guess. So I'll press Enter for a third time, and my calculator will now spit out the vertex, okay? Which in this case, 2.999995, that's close to 3, okay? So of course we'll just round that to 3. So my vertex in this case will be 3, 1, okay? My vertex is always a x, y. So I'm going to come over here to my t-table, and I have my x and y t-table here. I'm going to rewrite these a little bit bigger. X, y, so you guys can see it on the video. So I'm going to come down here about halfway, and I'm going to write my vertex. 3, let's do this in purple. So I'm going to write my vertex here as 3, 1. And I'm just going to put a little parentheses v. That just lets me know that's the vertex. And to graph a quadratic effectively, I really need 5 points. So I need to go grab 4 more points. And I'm going to go grab 2 to the left of the vertex and 2 to the right of the vertex. And the way to do that is I need to hit this table button in blue. It's above the graph button, right where my pen is, where my finger is. So I'm going to press second table, and now notice I have a table of values. Hopefully you guys were taught, your teachers taught you when you're graphing points to go to your XY table and pick 5 points. Usually it's 2, 1, 0, -1, -2. Well, in this case, I'm going to go ahead and scroll to my vertex. So I'm going to scroll to 3, 1. So there's my vertex right there, and I'm going to grab the 2 points above it. So I'm going to grab this point above it, which is 2, 2. I'm going to put that in my t-table. 2, 2, and then I'm going to grab the point above it, which is 1, 5, and then I need to grab the 2 points below the vertex, which is this point, 4, 2, and then I'm going to grab the point below it, which is 5, 5. Okay, I say thank you very much, Mr. Calculator. You've given me my 5 points, and let's go over here to our graph and plot it. So I'll go right 1, I'll start with this point, right 1 up 5, that's right there, and then I'll graph right 2 up 2. I'll graph my vertex, right 3 up 1, and then right 4 up 2, right 5 up 5, and there's my quadratic, and I can go ahead and connect the dots. There is my quadratic, which is exactly the way it looks. If I press the graph button and go right back, that's exactly the way it looks on the graph. So I feel pretty good. I've graphed this correctly. I've graphed it on the calculator, and I've graphed it by hand. So now I'm ready to go on and start answering all these questions. Okay. So for the x-intercepts, several different ways you can think about this. Okay. One of the ways to think about the x-intercepts is you simply look in your table and see where do I have a y value of 0. So if I go back to second table, I'm looking on the y column. Do I have a spot in the y column where I have a 0? I just kind of scroll up and down. Do I see any zeros in the y column? No, I don't see any zeros in the y column. That doesn't necessarily mean that I don't have any x-intercepts. It just means that if they're there, there's some kind of decimal. It's not a nice, pretty round whole number. Okay, but let's look back at our graph here. The x-intercepts mean where do I physically touch or cross the x-axis? Nowhere. This graph comes down, the roller coaster comes down, it gets really close to the x-axis, but it turns and goes back up and never touches it and never crosses it. Okay, so in this case, my x-intercepts are none. I don't have any x-intercepts. Okay, that won't always be the case. Most of the time, we do have 2 x-intercepts. Sometimes we may only have 1. Sometimes I may have a graph that comes down or comes up and barely touches the x-axis at one spot. In that case, I only have 1 solution. I only have 1 x-intercept. Now for the y-intercept, that's the spot in my t-table where x is 0. So let's look. Do I see any zeros in the x column? Oh, yep, I sure do. Right there, 0, 10. So this is the spot where it crosses the y-intercept whenever x is 0. So my y-intercept is going to be 0, 10. And that looks about right. So if I go 0 up 10 up to this spot right here, yeah, that looks about right. That's about where I've drawn my graph there. So my y-intercept is 0, 10. Now domain, this is where we get out our brooms, and I'm sweeping. So for domain, those are all of my x values. So I'm getting out my broom, and I'm sweeping from left to right. Sweep, sweep, sweep from left to right. What are my x values? Okay, and the domain for any quadratic, if the arrows go on forever, okay, the domain will always be negative infinity to positive infinity. I'll put parentheses around that. If I'm sweeping, do I have any x values out here at negative 1,000? Well, this graph goes on forever and ever and ever and ever and ever and ever and ever, way off the page. So way out here, if I come out to negative 100, negative 1,000, negative infinity, yes, I have x values. They're way up high. They're way up here, but they're there. Okay. So from negative infinity, sweeping from left to right, do I have any x's? Yes, 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 yes. All the way out here to positive infinity, I have x values. So that will always be negative infinity to infinity. Range, now that's going to be something different. Now I'm getting out my broom, and now I'm sweeping from the bottom to the top. With domain, I'm sweeping from left to right across the page. With range, I'm sweeping from bottom to top. So I always start down here at negative infinity. Do I have any y values down here? Look at the graph. Do I have any spots where my graph is touching any y values? No, I have nothing. Nothing, 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 nothing. I don't have any y values all the way up until I hit that guy right there where my pen is. Starting right there, I start having y values. And that is the spot that crosses right there at y equals 1. Okay, so yes, I have a range of 1. So I start picking up y values. Nothing, 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 nothing until I hit a y of 1. And then I keep sweeping up. Yes, I keep on having y values all the way up until positive infinity. Okay, now if I actually touch it, I have to put these little brackets. And my graph actually does touch y equals 1. So I'm going to put a bracket right there. Okay, I am including the positive 1. I can never touch infinity. Infinity is just an idea. It's just a hypothetical, theoretical idea. Okay, forever and ever and ever. I can never touch that. So I'm always going to put parentheses around the infinity signs. Okay. All right, oh boy, oh Lord help us. Here we go. Here, these next 4, these are the ones that everybody seems to have trouble with. Increasing interval, decreasing interval, positive interval, negative interval. Okay, so for these next 3 intervals, anytime I see the word interval, I only care about the x values. And maybe it will help if I put these guys in a different color. I am going to put all of my x values in red. So negative 8, negative 6, negative 4, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. Everything's in red here. 9, 10. I don't want you to look at the y's anymore. Forget about these guys. For the intervals, I don't care about these guys anymore. I'm not looking at these y values. Just X them out. Just imagine they're not there. I'm only looking at these red numbers. Okay. I know that may be kind of hard to see on the video, but okay, so I'm only looking at the x values. I'm only looking at these red numbers. Okay, so increasing and decreasing interval. Think about, I'll give you several different analogies, and hopefully one of these hits you. Okay, think about a roller coaster. Okay, this is a dip in the roller coaster. Okay, so where's my roller coaster going up? When is my roller coaster going down? Let's consider this. Okay, I got a roller coaster out here. When is my roller coaster going up? When is my roller coaster going down? When is my roller coaster going up? When is my roller coaster going down? When is it going up? From here to here, my roller coaster is going up. From here to here, my roller coaster is going down. From here to here, my roller coaster is going up. From here to here, it's going down, etc., etc. So it's like you're bracketing the spots where your graph or your roller coaster is going up or down. Okay, and I'm only looking at the x values when I'm trying to find these intervals. So if I go back to my problem here, I'm only looking at the red numbers. Okay, so increasing interval, where is my graph going up? Okay, well, starting here, my roller coaster is going down. I'm dropping. Scream Machine at Six Flags in Atlanta, I'm dropping, going down, 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 and then right here, I start to turn. And then my roller coaster or my graph actually starts to go up. So I'm actually increasing at this spot, but I'm looking at the red number. Okay, I'm looking at the x values. At what x value does my graph actually turn around and start going up? This is a x value of 3, okay, which you guys may notice is the x coordinate of my vertex. So these intervals, these increasing and decreasing intervals, everything's happening at the vertex. Everything's turning at the vertex. So everything's going to be happening at the x coordinate of my vertex. Okay. So from negative infinity way out here, my graph is dropping. I'm dropping. I'm going down, 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 down. So from negative infinity, I'm dropping all the way until I hit this x value of 3. Okay. So from negative infinity, my graph is dropping, roller coaster is dropping until I hit an x value of 3. Okay, and then my graph turns around and it starts to go up. Okay, so this actually I need to change this real quick. Let me change this. That was the decreasing interval that we just did. Okay, so I'm decreasing, so my graph is dropping all the way until I hit an x value of 3. So my decreasing interval, I wrote this in the wrong blank. So my decreasing interval is negative infinity. I'm decreasing, dropping until I hit an x value of 3. So from negative infinity to 3, I am dropping. Okay, and then my graph turns around and starts going up at 3, and then I'm going up, from 3 to 4 to 5 to 6 to 7 to 100 to 1,000 to infinity. Okay, so from 3 to positive infinity, my graph is actually going up. Okay, so notice in these increasing and decreasing intervals, I'm always going to have the x-coordinate of the vertex in here somewhere. Okay, and then it's just a matter of whether or not it's infinity or negative infinity. Okay, and let me give you guys another real world. You guys know I'm real big on these real world analogies, and I use this in class, but I think it's important. Let's think about a chart of a stock. Okay, let's say I've got the dollars per share, the cost of the stock, and let's say these are dates. So I have January, February, March, April, May, June, July, etc. Okay, so I'm looking at my stock, and my stock's kind of doing this thing right here. Stock's kind of going up, and then it starts to drop, and then it starts to go up again. June, August. So this could be a stock chart. Okay, so I'm looking at when is my stock going up. This is why you guys have to know this stuff, increasing and decreasing intervals. When is my stock going up? When is my stock going down? Okay, well, from January, I'll do this in, maybe I should do this, let's do this in red. From January, that's my wife's name, by the way. From January until about April, from J to A, from January to April, my stock is going up. So my increasing interval is from January to April. When is my stock going down? Okay, all right, from April until, what's that, about June? From April to June, my stock is going down. And then from June back to August again, my stock is going up again. Okay, so you could think about these as x values. If January were a 1 and February a 2, 3, 4, 5, 6, 7, 8, when is my stock going up? When is my graph going up? From 1 to 4, it's increasing. From 4 to 6, it's decreasing. From 6 to 8, it's increasing. So you can think about these x values as dates or something, okay? from this date to this date, from this date to this date, from this x value to this x value. That's why I only care about these x values when I'm looking at these intervals. When is it going up? When is it going down? Okay. So that's just kind of a real world example of when you could ever apply this, or why you guys are having to learn this stuff. All right, so let's go back to our problem here. So that's increasing and decreasing interval, which in my experience, students seem to have a little bit of a hard time remembering how to do these intervals. All right, positive and negative interval is a little bit different, okay? Positive interval just means when am I above the x-axis. So I'm going to do this in blue, okay? So basically I'm asking the question, when am I in this blue area? When am I above the x-axis? Well, look at the graph. Isn't that everywhere? Everywhere I'm above the x-axis. At every single red number, I can go up and touch my graph. So in all spots, I am above the x-axis. So my positive interval is basically all real numbers, which we write as negative infinity to positive infinity. Okay. The negative interval is, I'll do this in orange, where am I below the x-axis? And hopefully you guys, that's pretty obvious. In no spot am I below the x-axis. So I have no negative interval, none. Okay. The last couple of things that we need to address are the extrema. That's just another word for vertex. And we already said our vertex was 3, 1. So 3, 1. We're in vertex form here. I'll talk about this on another video, but I flip the sign here. This is my H and this is my K. So flip the sign there, so that's positive 3, and I'll leave the 1 alone, so 3, 1. The axis of symmetry. Okay, axis of symmetry is always going to be, let's do this in black here. The axis of symmetry is the line. It's always a vertical line for quadratics. It's the vertical line that goes straight down through and splits that vertex right down the middle. So it's a perfect symmetrical splitting of our quadratic equation. And that's always going to be, for any vertical line, it's always going to be x equals because it's crossing the x-axis. So my axis of symmetry will always be x equals. And then the trick is since it passes through the vertex, it's always going to be the x-coordinate of the vertex. So in this case, I just look at this front number. So x equals 3 is my axis of symmetry. The end behavior is exactly the way it sounds. How is my graph behaving once I get to the end? Okay, what's going on when I get to the theoretical very end of the rainbow? What's going on at the very end of my graph? Okay, so for the x's, it's kind of like your domain. The arrows, whether they're pointing up or pointing down, they're always going out towards negative infinity and always out towards positive infinity. So that never changes. In fact, they don't even give you an option on this page. They go ahead and fill it in for you. The y's, I'm just looking at where are my arrows pointing. When I get to the very end of the graph, both of these arrows are pointing up. They're pointing to the sky, right? So they're pointing up towards positive infinity on the y-axis. So my end behavior will be positive infinity to positive infinity. Okay. All right, so that's in standard form. Now let's look at another one. Oh, excuse me, that's in vertex form. That's in vertex form. So now let's look at one where we're in standard form. And let's look at one where we actually have some x-intercepts, because that's another spot where I feel like students sometimes get a little bit confused on how to use the graphing calculator to find the x-intercepts. Okay, so I have an equation. I have negative 2x, y equals negative x squared plus 2x plus 1. So let's go ahead and use our graphing calculator to graph that. So I'm going to go to y equals. If there's anything in there, just go ahead and clear it. I can enter in several different equations at the same time. My graphing calculator will plot them all at the same time, but so we're not confused, let's just go ahead and clear it. So let's type it. Now here I do need the negative button. I don't want to press the subtraction button. I want to press the negative button down here at the very bottom of the calculator. Okay. So negative, type in exactly the way you see it, negative x squared plus 2x plus 1. And let's graph it and see what it looks like. Now that there's a negative in front, I know there's an x-axis reflection. So I know my quadratic is going to be an upside down U, which is exactly what we see. All right, so now I know I have a maximum. My graph comes up, the roller coaster comes up, and it hits a maximum point, and then it drops back down. That is the maximum that my graph will go. It will not go any higher than that. It's a maximum spot. So now let's go second calc. We use this calc button a lot. Second calc, and I'm going to select, and this time I'm going to select maximum to find my vertex. So I'll select maximum, I press enter. Now my calculator needs a left bound and a right bound. If you're not sure where Mr. Spidey is, let's say Mr. Spidey were off the screen. If you can't find him, all you need to do is just look at the coordinates. These coordinates are telling you where Mr. Spidey is right now. So on my calculator, he's sitting at negative 3.6, negative 19. So he's way over here at negative 3, way down here at negative 19. He's way down here somewhere. He's sitting down here. So I need to move him up here. So I'm going to scroll to the right. Here comes there he is, Mr. Spidey. Hey, Mr. Spidey. All right, so I need a left bound. I just need some point that's to the left of that spot. Anywhere that's physically to the left. Okay, that spot will work. This spot down here will work. I'll go up pretty close. That's fine. Press enter. Now I need a spot to the right. So I move Mr. Spidey. Come on, Mr. Spidey. Move Mr. Spidey to the right. I'll come way down here. I'll go off the screen. It doesn't matter. As long as I'm to the right, I'm fine. And I press enter. And I press enter again. Yes, I want you to guess, Mr. Calculator. And the calculator spits out the vertex, which is 0.9999, which is just 1. So my vertex is 1, 2. So now notice Mr. Spidey is sitting right on the vertex. He's sitting there saying, I found it, Mr. Nice, I found it. I'm sitting here. I'm sitting on it. I'm sitting at 1 negative or 1 positive 2. So my vertex, so I'll come up here to my T table. Write this a little bit bigger. X, comma, Y. And let's write in our vertex. So 1, 2. I like to put a little V right there so I know that that's my vertex. And now let's go grab some points. So let's go second table. There's my table. So let's scroll to 1, 2. There's 1, 2. Let's grab 2 points above it. So 0, 1, and negative 1, negative 2. Let's grab 2 points below it. 2, 1, 3, negative 2. All right. Now let's go graph it. So over here on the right, let's graph. Let's go start with negative 1, negative 2. That's down here. 0, 1 is right there. 1, 2 is my vertex. So I know it better start turning right here. 2, 1, there it goes. Starts turning back down. 3 down, 2. All right, there's my quadratic. And that's exactly what we got when we plotted it with our graphing calculator. Both arrows are headed down. Okay, so now I've plotted it. So now the first thing that we're asked to do is find the x-intercepts. Okay, so in this case, I actually do have 2 x-intercepts. Okay, I've got an x-intercept right there, and I have an x-intercept right there. Just by eyeballing it, looking at it with my eyes, it doesn't look like it crosses at a nice, pretty number. But let's just check in the table. Do you see any zeros under the y column? If I scroll up or down, no, I don't see any zeros. All right, but I still know that I have some x-intercepts. I can see it. Okay, that just means there's going to be some decimal. Now, if you didn't have a graphing calculator, you would actually have to solve this equation, set it equal to 0, complete the square, use a quadratic formula to solve your 2 roots, your 2 solutions, your 2 x-intercepts. We have a graphing calculator, so we can use Mr. Calculator to help us find it. Here's what we'll do. Here we go again with that calc button. Second calc. Now notice I have a whole bunch of options here. I don't see x-intercept anywhere listed there. However, we've been saying this word in class for the past couple of weeks. Solutions, answers, zeros, roots, x-intercepts, they all mean the same thing. So when I'm trying to find the x-intercept, I want to select option 2 for 0. I want the 2 zeros. Okay, the 2 spots right here. Okay, where x is 0, where y is 0. Okay, so I'm going to select option 2, 0. And now my calculator wants to do the left bound, right bound thing again. And why does it do that? Well, here's why it does that. I'm going to put a big red dot right here. Make it a little bit bigger so you can see it. There's one of my x-intercepts. Here's my other x-intercept, a big blue dot. If I just ask my calculator to say, I want you to find me the x-intercept. Your calculator says, huh? What? What are you talking about? Which one do you want, Mr. Manice? Do you want the red one or do you want the blue one? I don't know which one you want, okay? So I have to bracket. If I want the red dot, if I want the red x-intercept, I have to bracket and tell my calculator, I want you to find the dot that's in between those 2 brackets, okay? I want you to find the red one. So your graphing calculator is asking for a left bound. So I physically need to go, here's Mr. Spidey, I physically need to move him anywhere to the left of that spot. Okay, now let me just kind of give you guys a blown up example, just to make sure we're all clear on this, because again, I feel like students kind of sometimes get confused on this. Let's say I have a quadratic, and let's say I have something that looks like this. I have an x-intercept. Let's move this up a little bit. I have an x-intercept at this purple dot, and I have an x-intercept at my Clemson Tiger orange dot. Yes, yes, orange and purple, lovely. Okay, so what I'm telling the calculator is I need to go to some spot physically to the left of the purple dot. Okay, so if I draw a vertical imaginary line down through this purple dot, I just need to be to the left of it, physically to the left. So I'm going to move Mr. Spidey anywhere on the spider web to the left. Okay, any spot to the physically to the left of that line would be good. And then the calculator is going to ask for a right bound, so I need to physically be to the right of this imaginary line. So I'm going to move Mr. Spidey on the spider web anywhere to the right. And then when I press enter, your calculator says, oh, okay, now Mr. Manise, I know which x-intercept you want me to find. You want me to find the purple one. You want me to find the one that's between these two red marks here. Okay, now I'm telling it exactly which one I want it to find. All right, so let's go back to, hopefully that analogy makes sense to you. So let's go back to our paper here, and let's go back to our calculator. So my x-intercept is this spot right here where my pen is. That's the spot. Let me move this back over a little bit. So make sure y'all can see in the video. Okay, so my pen right here is the spot of my first x-intercept on the left. I'll start with the one on the left. Okay, so I need to move Mr. Spidey anywhere to the left. He's to the left there, he's to the left there, anywhere to the left of that imaginary vertical line. And I'm going to press enter. Now my calculator wants a right bound. Okay, so I just need to move Mr. Spidey, make him hop on the other side of that imaginary vertical line. Just anywhere to the right, physically to the right of this point. That's good. I press enter again. Now my calculator says, Mr. Manise, are you ready for me to guess? Yes, I'm ready for you to guess. Press enter again, and there's my first x-intercept. So it's 0.4.41, comma 0. Let's keep this in purple here. So my first x-intercept is negative 0.41, comma 0. That's my first one. Now guess what? We get to do it all over again for the second one. So I do that whole process again for the x-intercept on the right. So I go second calc. I want 0. I want my x-intercept. Press enter. Now I need to move Mr. Spidey somewhere. Right now he's pretty much sitting on the x-intercept. So if I draw an imaginary vertical line through that spot, I just need to move him to the left, physically to the left of that spot. He's to the left there, that's good. Press enter. Now I need to move him physically to the right of that x-intercept. That's good. Press enter again. Yes, I want you to guess. Press enter a third time. And my calculator spits out the second x-intercept, which is 2.41, comma 0. Okay, so those are my two roots, my two answers, my two solutions. If I had solved this quadratic equation the hard way, manually, by the quadratic formula or completing the square, guess what I would get for my two answers? I would get negative 0.41 and 2.41. Those are my two solutions, my two roots, my two zeros, my two x-intercepts. Okay, y-intercept is where I have a 0 in the x column. Do you see any zeros? Yes, I do, right here. 0, comma 1, so that's my y-intercept, 0, comma 1. And that's about right. That's crossing the y-intercept right there at 0, comma 1. All right, so now my domain is always going to be negative infinity to positive infinity. My range, get out my broom. Okay, so let's move this up here. So let's get out my broom. I'm sweeping from bottom to the top. So I'm sweeping. Do I have any y values down here with my broom? Yep, I'm sweeping up some y values. So from negative infinity down here, I have y values. I'm sweeping up. I keep on having y values all the way until I get to a y of, that is a y of 2. Okay, so from negative infinity until 2, I have y values. And I always put this guy in brackets because I do physically touch y equals 2. All right, here we go, the tough ones, the intervals. All right, increasing, decreasing intervals. Okay, again, I'm only looking at these red numbers. So let me grab my red pen again here. So let's put these in red. So I got negative 3, negative 2, negative 1, 0, 1, 2, 3, 4. I'm only looking at these red numbers. I only care about the x values. Or if these were dates, I only care about the dates. From January to April, from negative 2 to positive 4. When is my graph going up? When am I going up the roller coaster? When is my stock going up? Well, way out here at negative infinity, I'm going up. I'm going up the roller coaster. I'm going up the screen machine. I'm going up, 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 all the way until I get to the vertex, and then I turn over. So at the x value of 1, the x coordinate of my vertex, right there, x equals 1, I'm going up, 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 up. Okay? So my increasing interval is from negative infinity. I'm going up, 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 up until I hit 1, and then it rolls over. And then I'm decreasing from 1, right there at the x-coordinate of the vertex. I'm going down, 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 all the way from 4 to 5 to 10 to 12 to 1,000 to 1,000,000 to infinity. So my decreasing interval is starting right here at x value of 1 all the way to positive infinity. I am decreasing. Okay. Now for the positive and negative intervals, again, I'm looking at when am I above and below the x-axis. Okay, so notice in this graph, the only time I'm above the x-axis is when I'm in this blue region, right? That's the only time I am physically above the x-axis. And that's between our original big red dot and our big blue dot. And what is the significance of those 2 points? Those are our 2 x-intercepts. So between the 2 x-intercepts, my graph is physically above the x-axis. So my positive interval will be from that guy, from negative 0.41 to that guy, to the other x-intercept. I am above the x-axis. So that means where am I below the x-axis? That means everywhere outside of this. So everywhere over here and everywhere over here, I am below the x-axis. Okay? So that means way out here at negative 1,000, negative infinity, way out here, I am below. I'm way down here. I'm way off the page down at the bottom. Yes, from negative infinity all the way, I'm below, 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 all the way until I get to the red dot, and then I poke my head up above the x-axis. Okay, so from negative infinity until that first x-intercept, so from negative infinity to negative 0.41, I am below the x-axis, and then I have a break in the action. And I don't dip back below the x-axis until I get below the second blue dot, which is the second x-intercept. So then from 2.41 all the way to 4 to 10 to 100 to 1,000,000, all the way to positive infinity, I'm always below the x-axis. I have a break in the action, so I'm just going to put this little U here, and that just means union. Okay, so those are my 2 negative intervals. All right. Now my extrema is my vertex, which we already said was 1, 2. My axis of symmetry is always going to be x equals, and it's always going to be the x-coordinate of the vertex. And that's a common thing. Everything kind of hinges on the x-coordinate of the vertex. That's very, very important. So x equals 1. That's where everything's happening. Line of symmetry, that's where everything's turning, increasing, decreasing. Okay, so x-axis of symmetry is x equals 1. Now my end behavior, where are both of my arrows pointing for the y's? They're both pointing down. So the end behavior, when I finally get to the end of the rainbow, I'm headed towards negative infinity down here on the left, negative infinity down here on the right. So negative infinity to negative infinity. Okay. So this is a little bit longer video, but I feel like it was necessary to make sure you guys were okay. So I encourage you guys to go back and pause the video, especially on the points where you're using Mr. Spidey to find the vertex and the x-intercepts, and make sure you guys are comfortable with those. And also on these positive and increasing and decreasing intervals, make sure you guys have a good handle on that. Well, that is it on this video. Hope you guys enjoyed that, and we will see you on the next one.